Okay, this is our lesson for today. Again, it's on the distributive property. And so we're going to start on some other things. So it says, use the distributive property to simplify the expression. So remember, we want to give that 8, distribute it to the numbers or the letters inside of the parentheses. So I'm going to take the 8 times the y plus the 8 times the z, which would be 8y plus 8z. And I can't combine anything there, so I'm just going to leave it at that. They don't have the same caboose, so I can't combine them, so it just stays that way. Okay, next, use the distributive property to simplify this expression. So 20, and then a subtract b. So I'm going to give the 20 to both of those. And so 20 times a is 20a, and then 20 times b would be subtract 20b. And again, I can't combine anything there. They don't have the same caboose, so no, they won't go together. So then let's think about this. Like terms, terms that have the same variables raised to the same exponents. So if they are alike, then we can combine them. So we can add the two whole numbers together, 27 and 18, which would be 45, and then we just have the 6g. Can you add these together? Do they have the same caboose? So we have 2a plus 6a plus 11. I can combine the a's together. So that would be 8a and then plus 11. So then if we have those like terms, terms that have the same variables raised to the same exponents. So if we have those, then if we took it backwards, we could say we have 2a plus 6, and then we have the a on the outside plus 11, because then we could distribute back out that a. So let's look at this one. Simplify the expression. 4y plus 10 plus 3y subtract 6. So if I combine like terms, I can combine those y's. So backwards distributive property or combine like terms. So first of all, let's combine the like terms. So I have 4y plus 3y, which is 8y. So I'm going to take the 4 plus the 3 and the y on the outside. That's why I would backwards distribute it. Sorry that the lines are in the way. So then that would be 7y plus 4. So let's look at this one. Simplify this expression. H plus 2h plus 3h. They're all h's. So actually I can put in 1h plus the 2 plus the 3. And then if you see, this is a good example of the backwards without lines in the way. But I can distribute that h back to each one of those. So I'd have h plus 2h plus 3h, which in the end would be 6h. So let's look at this one. Simplify this expression. If I give the 5 to both of those, then I have 5 times x, which is 5x, plus 5 times 3, which is 15, plus 1. Then I can combine those common terms, the 15 and the 1, and get 5x plus 16. So let's look at this one again. 8 plus 7 and then 3 subtract a. So first of all, if I distribute, I can distribute the 7 times the 3, which is 21. And I still have that 8, and then the 7 times the a would be 7a. Now what can I combine? I can combine the 8 and the 21 because they're just whole numbers. So that's 29, and then the subtract 7a. I can't combine it with anything because the 29 doesn't have a variable with it. Simplify the expression again. P plus 7p subtract 5p. So let's do that backwards distributive property again. So I'm going to take out the p and then see what I have left. I have 1p, and then I have a 7, positive 7, and then I have a negative 5. So then if I wanted to combine those together, 1 plus 7 is 8, but then subtract 5 is 3. So I end up with 3p. Then let's simplify this expression. 3b plus 7 subtract b subtract 6. So let's see what I can combine. If I do that backwards distributive again, then I have the 3b subtract the b. So what can I take out of that? I can take out, if I take the b out, I have 3 subtract 1. And then negative 7 plus, or positive 7 subtract 6 is positive 1. So it ends up being 2b plus 1. And let's simplify this expression. So I have 6 and then 7 plus 3f plus 14. So 6 times 7 would be 42. Then 6 times the 3f is going to be 18f, and then plus the 14. So now what can I combine? I can combine those two whole numbers, the 42 and the 14, which ends up being 56, and then I still just have the 18f. So it would be 18f plus 56. And let's look at this one. What can I combine on this one? So let's get that distributive property back. Let's get the k's together. So I have 5k plus a 6k. So if I take the k out, it's going to be 5 plus 6, which 5 plus 6 is 11k. And then I have plus 2.2, but then subtract 1.1, which ends up being plus 1.1. Sorry, those lines are in the way on there. So it's 11k plus 1.1. And let's look at this one. I have 9r subtract 2r plus 3/7r. So again, the distributive property, if I take it backwards, then I have a 9. If I took the r out, subtract 2 plus 3/7. So now I can combine those, which would be 9 subtract 2 plus 3/7 is going to be 7 3/7r. And let's look at this one. What can I do on this? Simplify the expression. So I have 4y plus 4 and then z subtract y. So let's distribute first. So 4 times z is going to be 4z. I have the 4y. 4 times y over there is negative 4y. So I have positive 4y subtract 4y. Can I combine those? Yes, which basically is going to cancel those out. So it's just going to be 4z. So let's look at this example. Carlos is playing a video game. He plays video games 6 days a week. Carlos plays for V hours. He watches video game secrets online for 1 hour, less than he plays. Write and simplify an expression that represents the amount of hours involving video games. So we have a couple things here, 6 days, V hours, and he watches video game secrets online for 1 hour. Write and simplify for 1 hour less than he plays. So write and simplify an expression that represents the amount of hours involving video games. So let's see. So why the parentheses? He plays and watches every day. So 6 days a week. So the 6 represents the 6 days a week, and he watches plays V video games, and then subtract 1 hour less than he plays. So now we have the 6 and then V subtract 1. So 6 times V is 6V, and 6 times 1 is 6. So 6V subtract 6. Can we add those together? Do they have the same caboose? No, so we can't add those together. So we're just going to have 6V subtract 6. So definition, this backwards distributive property is called factoring the expression. So on here, if we take out the p, we want to see what's left. So we have 1p plus 7 subtract 5. So then if I went back, the reason why it's called backwards is it's kind of the opposite of what we do when we distribute. If I distributed in, I'd have the 1 times the p, the 7 times the p, the negative 5 times the p. So then I can combine what's inside of the bracket. So 1 plus 7 is 8, subtract 5 is 3. So that's where we get that 3p. So factoring the expression using this distributive property to factor an expression in algebra. So when we want to factor, we can look for things we can take out. And if we're actually going to make it into a distributive property. So in AB plus AC, they both have an A. So if I take the A out and put it on the outside of the brackets, then I have B plus C. Or on this next one, if I take the A out of it, then I have B subtract C. So if you look at the examples on the right-hand side, the 4 and then the parentheses 9 plus 5 and 4 in parentheses 9 subtract 5, you can see that in both of them they took out a 4, and then they have 4 times 9 plus 4 times 5, and 4 times 9 subtract 4 times 5. So factor the expression using the greatest common factor. So in these type of ones, we want to find what's the biggest factor that I could take out of both of those. So if I think about it, what's the biggest factor that can go into 24 and 15? And I think it would be 3. So if I pull 3 out of those, they're going to find all the factors here. So 3 is the biggest factor for them. So if I take 3 out of those, then 3 times what is 24? And it's 8. And then 3 times what is 15? So it's 5. So it would end up being 3. Sorry, I know that the line's in the way, but it'd be 3. And then the brackets 8 subtract 5. So let's look at this one. What are the factors of 55 and 11? So factors of 55, 1 and 55, 5 and 11. Factors of 11, 1 and 11. So they both have 1 in common, but they both also have 11 in common. So if we pull out the 11, then what times 11 makes 55? And it's 5. And then what times 11 makes positive 11? And it would be 1. Sorry, I know that those don't show really quick, but it would be, so we take out the 11, and then it would be 5 plus 1. Let's see what we can pull out of this one. So what is the biggest factor I can pull out of both of these? So the factors of 3, 1 and 3, the factors of 12, 1 and 12, 2 and 6, 3 and 4. So what's the greatest common factor? What's the biggest number they have in common? And they both have a 3 in common. So if I pull out that 3, then what's left inside? What times 3 would make 3x? And it would be x. And then what times 3 would make 12? And it would be 4. So in the end, it would be 3x plus 4. And so that is kind of examples of how we factor out expressions. So go ahead now and go to your Go Formative assignment and work through it. And each of the questions has a video with it if you need some help on what to do on each question. And if you have any questions, then let me know. Thanks. Goodbye.